Kinetic molecular theory. KMT is a model which explains the properties and behavior of gases. Properties include the pressure, volume, temperature, and number of gaseous particles. And behavior includes the motion, energy, speed, and collisions of gaseous particles. There are 5 parts of kinetic molecular theory to be explored within the gaseous environment here. 1. Gas particles are in constant random motion. 2. Gas pressure is caused by collisions with the container walls. 'The container walls is best expressed by this equation. Pressure is equal to force over acceleration. Again, that's pressure is equal to the fraction here, force over acceleration. That's also expressed by mathematics here. Pressure over force over acceleration. Collisions are elastic. No kinetic energy lost. Now, 3. Attractive forces, or IMAFs, are negligible. Our IMAFs here is shown by the equation of the container. Attractive forces are negligible. We do not show them in our gaseous environment here. Four, the volume of particles is negligible. The volume of particles is a negligible thing in a gaseous environment. We do not talk about that when talking about gases. Volume of particles is negligible compared to total volume of container. In a 1 liter container, gas only expands into about 0.999 liters of volume, or about a little bit of everything of its whole volume. The whole gas volume of the gas is equal to the whole volume of the container minus a little bit less than the volume of all its particles. Here expressed by this simple equation. The volume of all the gas is equal to the volume of all the container minus the volume of all the particles here, expressed by this mathematical equation we see here, x'd out here. Negligibility, here expressed mathematically, here we see. Ideally, volume of the gas is equal to the volume of the container, but of course we know there's no perfection here now, do we? 1 liter container has 1 liter of gas, but we know there's no. Now, 5 particles of kinetic molecular theory, the 5th theory. The average kinetic energy of gas particles is directly proportional to Kelvin temperature. Average kinetic energy is about the average temperature. Kelvin is not Celsius. The average Kelvin and the average Celsius are 2 distinct values. K is about 273.1540 Kelvin. That is an important distinction to make, and one you need to keep in mind, and one that's being kept in mind for a long period of time. So that is an important thing to keep in mind. So that's an important thing to keep in mind. So, important thing also to keep in mind is the Maxwell-Boltzmann speed distribution curve shows in this chart that the kinetic energy, or 1/2 of the meter's volume squared, the kinetic energy is lower at the point where the volume is critically high right here. For us, where for 0 the 0 Celsius is 0 Celsius is a higher value, where 100 Celsius is